Good morning to one and all. Today we are going to see about the um, formation of Zbus matrix. Formation of Zbus matrix by using the bus building algorithm, and we are going to see the solved problems on formation of Zbus matrix or Ybus matrix by using the bus building algorithm. Take down this problem. Determine Zbus for the network shown in the figure below, where the impedance are given in the per unit. So here you see how many buses are there? 1, 2, 3 buses are there. And this is the reference bus. Zeroth bus is the reference bus. Okay. So 3 buses are there. Okay. And also impedances they are given in the per unit. For example, from first bus to zeroth bus, some 0.05 J. Okay. Then first to second bus 0.02 J. Next second to third bus 0.04 J. Next third to zero bus 0.02 J. Next here 1, 2, 3 0.15 J. Okay. So these are the values given in the problem. Now, what is the first step? The first step. So first, we are taking the first element that is from the reference node. Say, for example, this is the reference node. This is the new node. New node is 1. Okay. So the element between the reference node and the new node is j into 0.05. Okay. So here one element is there. So directly 1 cross 1 matrix. So directly you can write j into 0.05 j. So it is 0.05 J. So it is the step number 1. Next, what is the step number 2? Okay, so by taking this as a reference bus, by taking that second, okay, this as a bus 2, we need to add the second element. Okay, whatever the element given in the problem, that is j into 0.02. Okay, that is given in the problem. So what is the procedure here? What is the procedure here? So how to frame the bus? Okay, so here whatever given element given in the problem, whatever the elements given in the problem, so that you need to copy here, that you need to copy here. Okay, or otherwise, so whatever the element here, transpose of that is the element you need to take here. Okay, so even this one element is there, so transpose also same will come. Okay, so if 2 cross 2 matrix is there, then the transpose, the same thing will come here. Okay, so the simple thing to remember, whatever the element here, the same thing you have to copy here, same thing you have to copy here. Okay, so what is this element? This element, how to calculate? Nah? So whatever the element, okay, whatever the element here, that is 1 cross 1, the same element plus whatever the element new element added, new element added, that is j into 0.02. So 0.05 plus 0.02 j. Okay, so that is nothing but 0.07 j. So that you understood now. Next step. What is the next step? What is the next step? Next step. Yeah. Step number 3. Again, we are adding the new element. Again, we are adding the new element. So here, similarly, you need to follow the same thing. Similarly, you need to follow the same thing. How now? So here also. So here, whatever the element here, you need to copy here. Whatever the element here, you need to copy over here also. Okay. So here also. So previously from the 2 cross 2 matrix, whatever the element you need to copy like this. Okay. This element you need to copy this. So what is this particular element? This particular element is whatever this particular element is nothing but, so whatever the element you are keeping here, that is 2 cross 2, whatever the element 2, 2, that element plus whatever the new element add, that is 0.07 J plus 0.04 J. If we add J into 0.11 J will come. Okay, so that you can take down over here. that you can take down over here. Next, what is the step number 4? Now again, new node is adding. Okay, new element is adding. Okay, to the some reference bus. Okay, so now j into 0.02 j. Here also same story. So here, whatever the element coming over here, you need to copy paste. And here also, whatever the element coming over here, okay, so you need to copy paste like this. And here, this also, whatever the element coming over here, you need to copy paste here. Okay, so next step, here, this particular element, how to do this particular element is the sense. So whatever the element coming over here, plus the new element, okay, adding here. Okay, so here 3 cross 3, what is the element? 0.11 J. Here, what is the new element added over here? Yeah, it is J into 0.02. Okay, so this plus this J into 0.02 plus J into 0.11. Okay, so that comes the element over here. That is J into 0.13. So here simply we are keeping this element. Okay, this I think I hope this is clear. Now, what is the next step? Next step is just we need to reduce by using the Cron's reduction method. But here we are not using the Cron's reduction method. Instead, we are going for the shortcut. Okay, shortcut, whatever I taught. Okay, how to do this shortcut means how to do this shortcut. So here, yeah, here, whatever the, say for example, this is 4 cross 4 matrix. Now you need to reduce this for 3 cross 3 matrix. Now what you need to do? So you need to take this 3 cross 3 matrix, particular 3 cross 3 matrix. Okay, that you need to take outside. Okay, so that 3 cross 3 matrix you keep here. Okay, so whatever you take it, no, that 3 cross 3 matrix that you take outside minus 1 divided by this particular value, j into 0.13, j into 0.13. Okay, so into what is this value? This particular column elements, that is 0.05, 0.05 j. Next, 0 j into 0.07. Next here, j into 0.11. Next, whatever the row elements that you kept here. Okay, so simply transpose of this is this. Okay, so here what we need to do is that particular row elements alone we need to take. That is, yeah. So 1 cross 3. Okay, minus 0.055 j. Next, 0.07 j. Next element is 0.11 j. Okay, that's all. Okay, so simply like that, this 3 cross 3 matrix, this whatever is there that you take, simply reduce this. Okay, this into this. First you multiply this into this, and you multiply with 1 divided by into 0.13. One matrix 3 cross 3 matrix will come. Just this minus this 3 cross 3 matrix, whatever we got here, that same, this you need to take over here. This 3 cross 3 matrix minus whatever the answer coming over here, that you minus simply the answer will come. So this is our shortcut method. Okay, if you want to solve using the Cron's reduction method also, well and good. I'm not stopping you. you please do it. But this is a shortcut method. Okay. So next, simply the answer. Okay. If you do this, the final answer will be Zbus equal to 0.03 08J, 0.0231 J, 0.0077 J, 0.0231 J, 0.0323 J, 0.0107 J, 0.0077 J, 0.0107 J. Next is 0.0169 J. So this is the reduce matrix. Okay, is a plus matrix. Next, what is the step number 5? Step number 5, again the new element. Again the new element, that is adding from the 4 to 3. That is 4. Yeah, 4. Sorry. So if you see here, so this is how we calculate 1, 2, 3 up to here we completed. Again, now what is the new element added here? Again, what is the new element added here? Yeah, this is the new element added here. Okay, that is 3 to 1. That is J into 0.15. So this is the existing node already. This is not a new node. So already existing node, you are adding the element to a existing node. Already existing node means, so what is the step already we learned? Okay, so here's the same matrix you copy paste here. The same matrix you copy paste here. Okay, whatever the value you got, whatever the value you got, the same matrix you copy paste here. Okay, the same matrix you copy paste here. Next, here it is this particular thing you are adding from the third element to first element. Okay, third element to first element. So what we need to do is, the elements of third column and first column. So you need to subtract. Okay, you need to subtract this third row from the first row. Okay, or otherwise third column to first column. So okay, so here what we need to do is this particular thing is there now. This particular thing. This I am changing the color for your better understanding. Okay, so it is added from this to the here. Okay, third to first row. Okay, so what you need to do here is you need to simply minus this particular column with this particular column. Okay, so 1, 2, 3 you need to minus, because see here. Yeah, how it is adding? You are adding the elements of fourth column are obtained by subtracting the third and first column, and the elements of fourth row is obtained by subtracting the third row to the first row. Okay, so third column and the first column, third column and the first column. Here you are subtracting the third column from the first column. Okay, so here here also third row to that is the third row to first row. Third row. What is the third row here? Yeah, this is the third row. This is the first row. So this we are simply subtracting. Okay, so here what we are doing is, yeah, as I said, simply you are subtracting this. Okay, this minus this. Okay, this minus this. Yes, subtracting over here. That is J into 0.0308 minus J into 0.007 J. This minus this is this particular matrix we are getting here. So how to make this particular elements over here now? Just whatever getting over here, just a transpose. If you're making a transpose, you can make it here, or otherwise you need to again calculate it by using the third row, okay, minus first row. Like that also you can do. So simply for time, okay, time purpose. So simply whatever the elements coming over here, simply you make a transpose and you can copy paste here. Okay, that is the intelligent way of solving the problem, and time also you'll be getting the same. Next, what is the element? This particular element can be calculated by this already we have seen. So if not, you go back to my previous classes and you see that particular classes, how that is being solved. Okay, so what we did is this particular, say for example, this particular 4x4 matrix is nothing but, okay, so ZB, what is the new bus added? New bus added here from 3 to 1 is J into 0.15. Okay, plus Z11, Z11, Z11 is nothing but, what is Z11? So Z11, yeah, this particular matrix, that is this particular element, that is J into 0.0308. Okay, Z33, yeah, this one, J into 0.0169. Okay, minus 2 into Z13. Z13 is what? Z13. Yeah, this particular element. That is 0.0077. So minus 2 into J into 0.007. So that answer will come now. That answer you need to keep over here. Why? Because why we are going, you might have question, sir, why sir you are following this? So this particular element is added from the already existing node. This is not a new node. That is 3 to 1. Okay, so this is 3. Okay, this is 3, and here is 1. Okay, so 3 to 1 we are adding. So 3 to 1 we are adding. That is existing node we are adding. So this is the uh, steps that we have already seen in our previous bus building algorithm formulation. So if you don't understand this, you go back to my previous class and learn there and come back here. Okay, so this is the Zbus. So after that simplifying, you will get the matrix like this. You'll get the matrix like this. Now, again, we have to reduce the fictitious node, zeros node. Okay, say for example, here only 3 buses are there. Only 3 buses are there. This bus we have taken as reference node. Okay, so 3 buses means 3 cross 3 matrix only should come. Okay, now 4 cross 4 matrix is there. Again, what we need to do is we need to eliminate the fictitious node by using Cron's reduction method. But here in this problem, we are not using the Cron's reduction method. We are just going with a shortcut. Shortcut, simply I will explain you. Already I explained in the previous step also. Okay, so simply whatever the value, that is 3 cross 3 matrix coming over here, minus 1 divided by, okay, this particular value that is 0.1823 J. Okay, in scientific calculator, don't round off. Okay, so whatever the value coming after decimal, you take 4 digits. Don't round it off. You round it off. Sometimes your answer might be nearby answer only will come, because so my kind suggestion is for all you students is don't round it off. So whatever the answer coming over here, simply you take after decimal 4 digits numbers blindly. Whatever is coming in the scientific calculator after decimal 4 digits you take. Okay. So next, what is this? Yeah, this particular matrix, whatever coming over here. Okay, that you need to take here. And this column matrix, whatever coming over here, that you need to take over here. And this particular row matrix, whatever coming over here, that you need to take over here. Okay, so this particular row elements you need to take over here. Very, very simple. Yeah, if you just simplify this, your answer directly, you will get the answer. Okay, just what we are doing is we are calculating by using your scientific calculator. Then we are attaining the answer like this. Z bus equal to 0.0279J, 0.02153J up to 0.0164J. Okay, this is the particular answer. This is the particular answer for the problem, whatever the given in the this is the answer. This is the final answer for whatever the problem that we have seen the previous step. This is the answer for this particular problem. Okay. This kind of problems they will ask in the exam. This kind of problems only they will ask in the exam for 10-mark question or 16-mark question. So easily you can get the full marks. Don't lose any single marks also. If you're studying or preparing for your semester exam or in-semester examinations. So if you follow our classes regularly, you can easily score full marks in your long answer section. Okay, long answer section, say for example, it is 60 marks, sometimes it is 70 marks, sometimes. Okay, so you have to get full marks in the long answer section. Okay, 2 marks also you need to study. But the thing is that this kind of problem will come in 10-mark question full directly. Okay, this particular problem may come in 10-mark question directly, or in some other university, 16 marks. 16 marks directly. So don't even lose even 1 mark. Get full marks for this. So you can enjoy, okay, you can get more marks in your semester. And if you feel, if some of your friends feeling like this particular subject is very, very tough, you please share this video. It is very, very easy. Okay, so while looking only, if you just to go through the problem only, it will look odd. Okay, so if you follow our classes regularly, it is very, very simple. You can score full marks in this particular subject. Okay, like this problem only in exams they will ask.